Welcome to the Maine Science Podcast. I'm Kate Dickerson. We're back after a slightly longer hiatus than expected, and I can't wait to bring you more episodes about the people who are doing science in Maine. This episode is a conversation I had with Anne Lichtenwalner in early April 2022. Anne has been the director and diagnostician for the University of Maine Animal Health Lab since 2008. She's involved in research about and service to Maine animal industries, and in many ways, I felt like we barely scratched the surface of her work in our conversation. I hope you enjoy it as much as I did. And welcome to the Maine Science Podcast. I am delighted to have you here. You have presented at the festival quite a few times. Usually, if I remember right, with Ian as your co-presenter. I'm going to make you, in all the good ways, talk about your work at the University of Maine. But before we get there, I know scientifically originally from the West Coast. I don't actually know exactly where you grew up. So if you could kind of give us a quick background on how you got interested in science and how we got lucky enough to get you in Maine, that would be really cool.
Well, that was a nice way of putting it. Wow, I did not grow up interested in science, very interested in nature and loved animals. And so typical little girl in California, Northern California, I was just totally in love with horses. And that was my whole life. And that was never going to be anything different than working with horses my whole life. But I grew up in the suburbs, right? So didn't really have access. So it was an aspirational goal. When I got through high school, I started spending some summers working in the mountains of Northern California for a pack outfit. I was a wrangler and guide and learned to pack people into the mountains, and along the way learned to buck hay and shoe horses and many other things. I was a aberrant child. As soon as I graduated from high school, I took that little summer thing and made it my whole life for about 9 years. And along the way learned to become a vet tech because, you're living on basically nothing, but having totally such a great time, so much fun working in the outdoors and working with horses and doing hard work as a small woman. That was fun too, because it was kind of in your face to all the expectations about a 110-pound girl being able to shoe horses and pick up an anvil and things like that.
What was it about horses? You were in the suburbs, so it's not like you had easy access. I'm just curious was it a book or was it going to someplace where they had them and you just fell in love?
It's a very common affliction for young girls. It might be for boys too, but I think my experience has been that it's not quite universal, but close to it. I remember being in the car on a drive through the countryside when we were kids, looking out the window and seeing this thing in a field and going, I love that. I'm totally in love with that thing. It was a horse, of course. And so that probably wasn't my first, view of a horse, but it was just something about the symmetry of the animal. There's something about horses. It's just there. But after a period of time working with horses and doing other things you do when you're 20 or so, I realized that I was going to be the ancient vet tech assisting the veterinarian who had just graduated with his first spay, which literally happened, only I wasn't ancient when it happened. I was assisting this new vet where I was working as a vet tech in Northern California, and we were chatting, and he said, well, how come you're not studying to be a vet? And I said, oh, I'm too old. Because I was 21 or something like that. I said, no, I'm too old to start now. And he goes, oh, okay. Then he thought for a second, he said, but I don't know, what else are you going to do with the time? And I thought, well, I actually never thought of it that way. And so that was I thought, okay, well, I guess I need to change my goal. So long answer to your short question, but that is really honestly what it was. I got to follow something I loved and then realized that I wasn't going to get to a place I wanted to be by following that road the way it was going. And so I felt I needed a more personally sustainable goal that would keep me interested and engaged and also give me a reasonable living. I mean, I didn't want a lot of money, but I definitely didn't want to be cleaning out cages and when I was in my 60s.
Right. Yeah.
Not that there's some dignity to that and everything. You can do it well. It can make you happy, I suppose. But for me, it wasn't going to be the route,
It's also really hard physical work. I mean, at a certain point, right?
Yeah.
Your body may not last that long.
We hate to even ever admit that. But
certainly not in your 20s, right?
Yeah, I know. That's right. But now I'm kind of having to bump my head up against a little bit of that. And some of it's the residue of what I did in my glorious 20s. I mean, I'm sorry, but shoeing horses, and I was doing a lot of hot shoeing. So I was doing a lot of work on the anvil. So, just that repetitive concussion, metal against metal.
What I find most interesting, and you can dive into this a little bit, is you did get your doctorate in veterinary medicine, but then you went and got a PhD. So was that a matter of finding out that the track that you thought you were going to love wasn't quite what you thought, or was it more you fell in love with something else as well?
Yes and no. I still love veterinary medicine, but the daily practice of the veterinary medicine can be highly repetitive. And sometimes the challenges you feel a little stymied because you're aware that the challenges are there, but you're not always allowed to meet them. So each little animal that shows up on your exam table comes with a human attached, and they wouldn't be there if it weren't for the human attached to them. It's all about that relationship. So that human also has a checkbook or credit card, and they are protective of it, and they should be. And you don't get that when you're, fresh out of vet school. You think, okay, it's all about me and my powers to heal and diagnose. And so here's the list of all these wonderful things that we should do because I just laid my hands on your animal and we need to answer some questions. And I'm not making fun of clinicians because they're good at what they do. I felt though, and I've seen this in other recent grads, I felt very frustrated because I couldn't answer the questions I wanted to answer. Instead, people would always, they need to be guided by their economics, right? And so they would say, well, you've offered me 5 different options. There's one option that you mentioned at the very beginning, which was let's wait and see, or let's try an antibiotic and see what happens, et cetera. And those are usually the things you do. So the rest of it turns out to be this glorious intellectual exercise, and you just, well, shoot, I can't answer questions. So I was more impatient than some people, perhaps. And also I had another opportunity come up, and that was to work with a group that was investigating reproductive questions, research questions in the horse as a model. And there was a PhD available at University of Idaho. So I thought hard because I was in a fun practice situation up in Bainbridge Island, Washington State. Yeah, it was a very beautiful place, and was mostly working on hunter jumpers and some llamas and alpacas, and then I did a little bit of small animal work as well. So it was really interesting. A lot of it was great, but I was again kind of stymied and frustrated by the limitations of practice. And I thought, well, what the heck? If I were to do research, then it's all about diving deep in on some question and creating some new knowledge, which sounded like a complete and utter intellectual thrill to me.
Just because I'm curious, when you started vet school, or when you were working, as what did you say, you were a vet tech before you went to school.
Yeah.
Were you always kind of asking those questions to yourself, like what's causing this? It wasn't a matter of just making sure the animals were comfortable or whatever, but if something came up with them, were you always kind of asking yourself, like, what's going on here?
Oh, yeah. Oh, I was obnoxious. The guy who hired me is a lovely man. Stephen Wixie. He and his wife started a practice in Scott Valley, Northern California, not the one that's middle of California, but it's a wonderful little mountain valley agricultural place. I happened at that time to be living in the mountains where I had been working as a wrangler and guide were right near there. Anyway, so I got a job working for him, and he gave me on-the-job training. At the time in California, that was legal and okay. That was how you got trained as a vet tech then. And he taught me a bunch of lab medicine, and he taught me how to set up a bacteriology lab and run like all the mastitis testing for the local dairies and things like that. He taught me so much. And he didn't put boundaries on my questions and things like that. And so he encouraged me to dive in a little deeper on these things. But a client would come in, okay, there was a 4:00 appointment, say, okay, I'd get him in the room, I'd ask him some questions, I'd take the animal's temp, I'd do all this stuff. And then occasionally I would maybe run a couple other little tests or something. So that by the time he actually saw the animal, I was telling him what the diagnosis was, which was entirely inappropriate and not professionally correct. And I remember the day that he took me aside and very kindly, in private, very kindly said, there's this line, and as a technician, you don't go beyond that, okay? Because that's actually requires a lot more years of training and experience to get in that spot to responsibly give that information. And when he said that, I thought, guess I need to think more about my career. And then it was a new vet that he had hired that gave me that complete and utter aha moment when I was prepping the dog for him. Like, oh yeah, I guess I need to carry this journey onward.
So you had a really spectacular mentor who didn't squash you, but also made it really clear what was legitimately you could do and couldn't do.
Yes. Yeah, that I think is really, being a mentor is an interesting skill set, because
it's really hard.
Yeah. And it's so cool to have had some in your life that you can reach back to. I had both women and men act as wonderful mentors to me at different stages in my career.
So back to horses as a model for pregnancy and Idaho. Yeah. So it sounds like you've always been focused on large scale.
Yeah. Large animal, small animal sort of dichotomy.
Thank you.
At med. Okay. Yeah. Mm-hmm.
We don't have to dive into your PhD work. I just think it was really cool that you were still able to work with horses and learn stuff.
Oh yeah. Yeah, that was pretty neat. I also though walked in the door and I had this. At the time, there was a big deal about llamas and alpacas. So we refer to them collectively as camelids. So they're camel-like animals from South America for the most part, actually originally in the Pleistocene from North America. So obviously I know I have some in-depth knowledge about this crazy group of animals, but I was very excited about them. And at the time, like one llama, even an ugly one, would go for an average of about $25,000 in the United States. They were a boutique item. And how sometimes there are these pyramid schemes with things. Well, the deal was that because of foot and mouth disease in South America, they were banned from being imported into the United States, except if you were to put them in quarantine for like 2 years offshore in one of the, so these USDA run quarantine facilities. So it was a big deal. And some people had bothered to do that. And so they had a few of them in the United States, and they were, again, a big deal. And we didn't know that much about their basic reproductive physiology. So to me, this was, A plus B equals C, and C was, we need to publish some of this information because we were this reproductive physiology research setup at University of Idaho. It was a really nice setup. So I talked to my major professor into letting me do some of my research on llamas, which was really super interesting. And we had to get a herd of llamas together. So I actually spent my first year of my PhD driving around the Northwest, picking up llamas from llama and alpaca owners who were willing to donate these valuable animals to our university, which I think made them deductible.
That's still a serious level of persuasion that you were able to make happen.
It was pretty good. We want your ugly but reproductively normal llamas that you may have kind of been scratching your heads about, like, what am I going to do with this one? Because he can breed, but nobody wants it. He's ugly. So anyways, we ended up with this lovely herd of ugly llamas that were reproductively normal, and we published some work in that area. So that was
super cool. So was it, you were looking at both equine, horses and llamas, and was it a comparison, or was it just totally separate studies?
Totally separate, two very separate things, So I have my PhD thesis is reproductive physiology in the male llama and the events of very early pregnancy in the mare.
Okay, so how did Maine get you? How did we get lucky enough to get you over to this side, this coast, this part of the country, which is not necessarily known for llamas? There are some alpaca farms in Maine.
There are actually, yeah. No, and some wonderful ones, by the way. I just did a really fun collaboration with the one that's right there in Unity.
Oh, cool.
Northern Solstice, of course. Yeah, they're terrific. The luck is on my side. So my paternal grandmother is a Haskell from the Augusta area way back when.
No kidding.
Yeah.
That's so cool.
I have some Maine roots. I have a great aunt who's a Chadbourne. So she grew up around here as well. But my brother came out here in the late 70s, early 80s, and he moved out to work with a boat builder outside of Damariscotta and stayed, and he and his wife raised their kids in this area. And then they came back out to the West. And he always said to me, if you ever get a chance to go to Maine, you need to go to Maine. You're going to love Maine. And this job came up. I won't go through my career in detail, but I was living in Oregon at the time, and I was not doing an academic job. And this academic job came up, and I wanted to get back into academics and thought, wow, I should jump on this. And the person who alerted me about the job was a former lab mate from that equine physiology PhD experience that I had. So who is still here at University of Maine, Jim Weber, great guy.
So could you explain what you mean by an academic job in this sense, in the sense of, I mean, I think I know what you mean, but it would be helpful.
Sure. Yeah, no, so I have a DVM and a PhD. So I have a clinical professional degree as a DVM, and then I have a PhD, which allows me to do teaching and academic work. And so by an academic job, I mean that a job working for the university that does involve some research and teaching. So that this particular job also involves some clinical service in that I run the veterinary diagnostic lab. So for instance, I do a lot of chicken necropsies. I do a lot of sheep and goat necropsies. We do the occasional horse and cow and pig. So we provide service directly to farmers and also to veterinarians here in Maine. So in that sense, it's kind of like a clinical job, but I'm working for the academic institution, and I get to work directly with students as well. So I have right now, I have 7 students who are at various stages in their training, and I'm mentoring them in projects that interest them. So, some of them have to do with vector-borne diseases. We have some cool projects going on with snails and some of the parasites that they can carry between wildlife and livestock, things like that.
So do you work mostly with farmed animals, or do you have any work that you do with the wild herds as well?
Yeah, so it depends on the year.
Okay.
A few years ago, we had a lot of collaborative work going on with IFNW, with Inland Fisheries and Wildlife, on moose health. And so there were several years in a row that we did that. And now we're working with Pauline Kimath, who's a colleague in the School of Food and Agriculture. She's also in the Animal Vet Sciences group. And she's got some great students and has been doing some wonderful work on communicable diseases carried by ticks that moose can get. And so we'll probably continue doing some work in that area. And then also the work that my grad student is now doing has its roots in this brainworm, a parasite, Paralaphostrongius tenuis, that's carried by white-tailed deer and ends up in our ruminant livestock that can die from it, although the white-tailed deer is not affected by it. So I'm at that crossroads. I've tried to kind of step away a little bit from working directly with wildlife and then do support work that is closer to the intersection between the wildlife and the livestock.
If you could talk a little bit about the snails and kind of how that, well, first of all, how the project came about, but also how it is working in that compared to the much larger animals that you also work with. In this context, chickens are definitely much larger animals than snails, but I'm also thinking of the alpacas, and I assume you've worked with some dairy farms as well.
Oh yeah. Being a vet is, it's just fundamentally a complex sort of thing, because unlike an MD, you're working with a plethora of species. Even if you follow that dividing line between the large animals and the small animals, which I've not. I kind of have done a fair amount on both, but even if you do that, you still have a huge amount of complexity to engage. Just think about the size of dogs relative to each other, right?
Yeah, it's crazy. It doesn't seem like they should all be the same line. So
yeah, you really want to get into an interesting conversation sometime. Start talking to a physician about dosages of any drug that they use, because they probably have an adult dosage and a child dosage, but breaking it down more than that is not done. And so then talk to a veterinarian about the dosages they use for dogs. They have by weight dosage, almost exclusively, except for drugs used for treating cancer. And then it's by body surface area.
Whoa, that's super interesting.
It's super interesting because every time, if you have a Chihuahua come in, you weigh the darn thing, and then you calculate what the body surface area is. And then you carefully, and for each animal, calculate the exact dose that you're going to use of the drug. Do you think that happens for people? I weigh, probably a little more than I'd like to, but I'm, just over, more, I'm closer to 100 pounds than I am to 150, for instance, and far closer to 100 pounds than 200 pounds. But in human stuff, I get the same dose as someone who's, much bigger or much smaller sometimes than I am. And that just makes no sense to me at all. So that's again, a very long answer to a short question.
I love the long answers. So back to snails. How'd you get in the snail thing and what are you looking at?
Okay, good. So that boils down to, and this is fun because this pulls all this together. Every once in a while, I get a phone call from a sheep or goat owner, usually, saying, I've got this weird problem. My animals are fine, but then one of them it's like he got chopped in half. It's like his back end doesn't work. It's like he has spinal trauma. And there's no there's nothing that happened, nothing at all. But he is down in the hind end. I had one that was down in the hind end and then he died. And I don't know why. Do necropsy, figure out what. And so then I became more aware in sleuthing that out years ago. I thought, I think this is this brainworm thing, which a lot of vets down at a fellow that's now retired from Cornell who was a neurologist, veterinary neurologist. But anyway, he always said, if there's a sheep or goat and they're lame in the hind end and you're not sure what it is, then by default, it's brainworm, Paralaphostrongerus tenuis. It's that migrating parasite because that is what it does. And so while I can't say for sure that he was right about a lot of things, he's an amazing guy, but that's how it presents. And so that is this little migrating parasite. They get it from grazing where these snails have been. The snails get it from the white-tailed deer poop. And it replicates within the white-tailed deer very happily in the meningeal space above the brain, very close to this, of course, the spinal cord and the brain, but doesn't damage them, does not, to our knowledge, damage this definitive host, the one in which it breeds, the white-tailed deer. So that pulls together the sheep and goats and the wildlife, right, via this parasite. And of course, intermediate host necessary, but intermediate is the snail. So that the snail, it matures in the snail, gets to the point where it can actually infect those either another white-tailed deer while grazing or those innocent sheep and goats that end up eating it. And then it can't migrate in the sheep and goat quite the way that it can in the white-tailed deer. And so what it does instead is it damages the nerves. So in the white-tailed deer, it goes along the nerves and up to the brain along the nervous tissue without damaging the nervous tissue. In the sheep and goats, it kind of loses its way a little bit and it damages those neurologic structures instead of just migrating along them.
Are those sheep and goats eating the snails and that's how it's getting into them?
They either eat the snails or they eat snail slime where the snails have been, but it is carrying, the larvae are shed in that slime or are present in the snails.
So it's both. It could be either or.
It could be either or as we understand it. This
interesting.
Yeah, the life cycle and everything has worked out. It's been known for a long time. It's not like we discovered this. So this is also affecting moose, by the way, another thing that I'm interested in. How can you not be in Maine? And it was considered to be the big, huge thing that was knocking moose down at a certain point in time, a number of years ago. There's some folks in Canada who did a lot of good work in that area, including some people here at UMaine did some good work on that area. Now we think it's more kind of a mixture of parasites, but we certainly have a problem with these winter ticks. But anyway, that's another story. On the snail story, I might have just been talking about this to owners and saying, okay, here's the life cycle, blah, blah, blah. But I kept getting phone calls from people. Like there was a young woman who had a herd of goats that she would hire out to clear brush. She was running a business doing that, but she was losing some of her goats to meningeal worms. So she was troubled by that. And a couple other calls made me think, we need to kind of get a project going on this so people can kind of assess, is this a big deal? What are some of the things we can do about it? And so then I had this phone call from this really nice young lady who was this really cool person who was interested in doing some research. She was teaching and doing a lot of work in the state on environmental causes and things like this. But she and her husband had a small herd of sheep and goats, and she had lost one putatively to brainworm. And she was interested in that whole thing. And I said, oh, we need to talk. So it was her losing some animals that fostered her interest. And it was all of those things coming together with a lot of my interest in parasitology and, livestock, wildlife disease and things like that. And then Rachel White, that's the person of whom I speak, ended up getting associated with my lab doing a master's degree in animal vet science. That's how we started. And then we got this wonderful, huge grant here at the University of Maine, the One Health and the Environment. to foster graduate studies. So it's called an NSF NRT. And we're just so happy to have that support from the National Science Foundation. And so Rachel is now doing her PhD on brainworm risk assessment for farmers and methods for reducing brainworm on pasture, funded by NSF. And she also had some wonderful funding from the USDA in the form of one of these Sustainable Agriculture Research and Education SARE grants. So that was pretty cool.
Very cool. I'm going to get back to what you had mentioned about parasites in a minute, but is it to understand the whole impact of the snails and the brainworm within these different herds, or is it also to try to figure out a treatment, or is it just to get the basic understanding of why it's so damaging to these livestock, but not necessarily to the white-tailed deer? I guess that what I'm asking is it basic level research to understand it, or is it the next step of now what?
Our work oftentimes will try to take a wicked problem, an applied problem, and try to explore methods of understanding it and methods of dealing with it. And we can get into basic mechanisms. We've done that with other students in the past years, like some of my capstone students. We looked at immunology of the macrophage response against Corynebacterium pseudotuberculosis, and things like that. In this case, we're keeping it very much on the applied level because Rachel's also very interested in social science aspects of it. So she wants to understand what farmers can do, and not just that, but also how do they handle risk in general on their farms. So this is going to have some interesting spin out, I think, that she may choose to develop in regards to PFAS and other things that are definite risks to agriculture here in Maine, but that farmers need to kind of be resilient against if they can, know where to reach out for help and utilize those resources intelligently so that they don't get snowed under by some of these recurrent problems. So this one has some myths to bust. We've developed several other projects along with this. So the microplastic, we're looking at a lot of snails in the lab, and we found a lot of microplastics in these snails. So we thought, well, let's address that. That's a different student, Denise Cole. She's been working with Rachel on Rachel's PhD project for the last over a year. But anyway, she wanted to survey farmers and find out, where are these microplastics coming from? How would you think of that? And might you try to, do things slightly differently to keep that from happening, et cetera. With Rachel, I think that she's constructed the study of these 6 farms herself. And she is the primary person communicating with the farmers and talking to them. And so she's also able to put some narratives together about kind of what are the realities. And these are wonderful people that are, for the most part, really well-educated people. They've chosen this lifestyle. There are some things about how they make it work for themselves that'll be transmissible information for other people who want to try to do what we do well here in Maine, which is run small farms as a lifestyle sometimes, not necessarily a way to get rich, but,
Right. It's a super interesting project to me because it's really cross-disciplinary in a lot of ways, right? She's not just looking at, I hate the phrase hard science, but it's just such a good shortcut. But,
yeah,
there's a really important lab aspect to this, but also the social science part.
Mm-hmm.
We don't talk about enough, and I don't talk about enough. I shouldn't say we. It's the part of science that I am the least versed in, but I find it really fascinating.
Well, I think there are a lot of things in science and in many parts of our lives that are one up, one down. And so with basic science and applied science, that's kind of traditionally been a one up, one down. One of them is more serious, rigorous, and only engaged in by the elite sort of thing. And then one of them is more like, let's citizen science, or it's very applied. We think that probably, in the One Health and the Environment program, what we want our students to be able to do is to feel like they can touch on both worlds and pull in what they need, so that they feel comfortable and not disallowed from one or the other world. And so we want our students to feel like they could influence policy because they know how to communicate across those lines. We're still kind of in the infancy of that NRT. We're still recruiting, students, and we're still interested in exploring and building policy aspect of it. We feel that, we've got a bunch of scientists who are both biomolecular and also, like in my case, more applied whole animal. And then we have some social scientists, including economists and anthropologists or two, and that sort of thing. So we're hoping that we get this kind of programmatic mixing of skills to build the infrastructure even farther.
You mentioned parasitic research. That's what you presented on at different parts of the festival. And I know it's a passion, I think is a fair word, but it's at least super interesting to you. And maybe you can connect some of the dots for us about why you're interested in it, but also how it aligns with what you were talking about with how you're really actively trying to work with farmers in Maine and others who have to deal with what is often an unseen by the human eye thing that deeply affects their livelihood.
Sure. Most people are familiar with Gary Larson.
Yeah.
The Far Side.
Yeah.
What's not to like about Gary Larson, right? He's crazy. But he was a parasitologist.
Oh, I did not know that.
Yeah, from Washington State University, where I did part of my DVM. So I think that what's not to like about parasites? The horrible little monsters, and they live inside us. And we have our own, right? Everybody has their own. So it's kind of like the microbiome, right? It's all those little germs that we were taught to think were so horrible when we were kids and learning how to wash our hands, right? But in fact, we are all consortiums of these myriad little beings. And for some reason, we get to be the directors in the world that we think we're living. So they're fascinating. And I worked for several really good parasitologists during my training as a veterinarian. I was just very, very lucky to stumble onto, I needed a little work, needed some money, I was broke. And so I got to work for this guy, Bill Ferret. It was just, marvelous warped sense of humor. But I think that there's just something about these creatures who do such weird things with their lives to make them work. Think about the Arctic tern. There is a bird that migrates literally the whole globe in a given year, right? Pole to pole sometimes, and yet they have parasites. So how does that happen? Those little hitchhikers have to be able to live, to be very, very good at getting into the next bird, right? So they only show up at certain times, and they have to only pass their eggs when there's land to receive them, and things like that. So it's just really many, many, many complex and fascinating stories about life cycles with parasites. If you just look at money, they are of huge concern to any animal owner. So your dog could die of heartworms carried by a mosquito. That doesn't even normally exist up here, but that's another climate change issue. You need to spend money to keep fleas and ticks off your dog, right? I'm just focused on the dog and the cat right now. And those are animals, those fleas and ticks are dangerous to you and your family. So parasites actually are one of the big expenditures and big losses that agriculturalists also have to fight. So I deal with parasites all the time. And so what my whole thing is just, if you can avoid them by understanding their life cycle and changing it, like Rachel's work with the gastropods, we'll come back to that. But Rachel's work has to do with doing things like using pastured poultry to eat the little dickens before you get your sheep and goats out there. It's actually moderately effective. So we have some other work. Another student, another hitchhiker project sort of on this one, a capstone student's project was, hey, well, what about ducks? Could you use ducks? I always thought ducks would be great. But we found that the ducks eat the snails, but the snails pass right through the ducks because their GI transit time is quite short. And so they don't necessarily kill the snails or the larvae. So you might be translocating the problem, but you might not be eradicating it, at least with the ducks. We don't know yet about chickens. Yeah, so I think that parasites are fascinating. I think they are worthy of study. They are not as popular to study these days because of the molecular tools that we use. The techniques that parasitologists tend to use have always been more whole animal, sort of microscope level, things like that. And not everybody's doing those kind of studies anymore. And some of the fundamental studies were done in the 1920s and 30s and 40s and things like that. So it's still interesting and just applying, that's again, very applied science, but very important applied science.
Are there parasites that you know of that are beneficial to one animal species and then really terrible to another animal species that's nearby? And so if you treat it for one, it could actually hurt the other.
Well, a simple, robust answer to that doesn't jump to mind, but certainly you can treat some animals for one thing and put yourself more at risk of problems with another thing. So an example gets back to the llamas and the sheep and everything, but an example is guard llamas in pastured sheep production. So a lot of people use guard llamas. What's a guard llama, right? It's a very worried llama that wants to know, why in the heck is that? What is that coyote doing in this flock of sheep? I'm going to go find out. That's what guard llamas do.
Wait, so seriously? It's guarding that?
Yeah, it's guarding the sheep.
That's awesome.
Yeah. If you see one in action, it's pretty fun because they can be quite aggressive and they run at you. They have eyes and they're humming or they're making some funny, interesting noises and they get right in your face. It's like, okay, I guess if I were a coyote, I might leave. But they are also very susceptible to the brainworm. It's not all about brainworm, but I think a lot about brainworm anyway. So what people tend to do is they don't want to lose a guard llama. They have more money in the guard llama than they do in the individual sheep. So they want to spend some money on the guard llama to keep it safe. So they give it monthly or every couple months ivermectin injections. So we all know ivermectin, right? It got ill repute during the COVID situation. They're still putting out papers about how it's ineffective against COVID. But anyway, it's also a very effective livestock wormer against some worms, and it happens to be effective against the migrating form of the brainworm. So that is one way that people handle the risk in their guard llamas or in their sheep situations. But the thing about it is that some of the other parasites that both sheep and llamas can carry, one of which is Haemonchus contortus, which is a barberpole worm, is a big, huge problem to the sheep and has a very strong predilection for becoming resistant to wormers that you want to use. So when you worm your llama against the brainworm, you may be setting up antimicrobial or anti-anthelmintic resistance in other parasites that are affecting your sheep in that area. That's not a great idea. It maybe in the big scheme of things, it isn't quite as big a deal as losing your llama and having your sheep fall prey to a marauding pack of coyotes or something, but
Right. So one is a short term and one is long term. And
right.
So I guess one of the things that seems like you're studying and really interested in is understanding how systems work so that long term you're not putting even more at risk.
Right. So it takes rethinking of some of these easy push button sort of solutions. So farmers sometimes, if they're trying to farm in ecologically balanced paradigm, and a lot of our farmers are very, very devoted to that idea, they may have some difficult choices to make sometimes. And you kind of have to not bank everything on being 100% successful. So, are you willing to lose a few animals because the risk of thing or another is incipient, but might not put you out of production completely? It's living close to the landscape is inherently, it's, I don't know, it's not a slam dunk. There are a lot of risks to it.
Well, I'm grateful that you're here in Maine and helping people with those really hard decisions and your innate curiosity in trying to figure things out. I wasn't kidding when I said I could talk to you about this for hours, but no one wants to hear that. So
I appreciate the ear. It's fun.
My pleasure. This has been really great and really interesting. And I feel like we just scratched the surface of all the cool stuff you're doing. Like I said, I'm really grateful that you're doing it. And I think it's fantastic. You said you had 7 students. Is that a mix of master's and PhD students?
Actually, really, I have mostly undergrad students. I've been really
very cool.
Yeah, I've been so happy working with undergrad students doing research. It's really fun because they're usually ready to launch on one thing or another. Sometimes they come in as freshmen or sophomores, and I have them for 4 years. And then if they do stay with the plan of going to vet school, and many of them are successful and get in, but like the one who did the duck work, she's at Cornell now. But if they do stay with that plan, then they are always thinking, I could think about a research career. And some of them don't stay with that plan. Some of them go on to do research as they change their tune a little bit, which is really kind of cool too.
Yeah, and it really good for science. You've got people who have this understanding of the whole critter they think, but then they do a deep dive, much like you did with all of your questions of how does this work? So And I'm really grateful. I appreciate your time, and I really appreciate the chance to put just a little tiny spotlight on the work that you're doing.
Well, thanks so much for lending an ear. Appreciate it.
My pleasure. Thanks for listening to the Maine Science Podcast. Make sure you never miss an episode by subscribing on your podcast platform of choice. And please leave a rating and review. It will help more people find us and help spread the word about some of the remarkable people doing science in Maine. The Maine Science Podcast is recorded at Discovery Studios at the Maine Discovery Museum in Bangor, Maine. The Maine Science Podcast is hosted by me, Kate Dickerson. This episode was edited and produced by Scott Loiselle. We received financial support from Central Maine Power, production support from Miranda Bouchard, and social media support from Next Media. The Discover Maine theme was composed and performed by Nick Parker.